This video covers section 7.3 in your book, talking about functions and especially linear and nonlinear functions. The basic objectives are to learn to use the vertical line test to test for functions, to understand linear functions, and to understand nonlinear functions. Our vocabulary includes the vertical line test, which tells us that if it is possible for a vertical line to cross a graph more than once, then the graph is not the graph of a function. And we'll look at some examples of that to make that more clear. A linear function is a function whose graph forms a line in the form of f of x equals mx plus b. Should look very familiar to you. That is slope-intercept form. M is the slope, and b is the y-coordinate of the y-intercept. A nonlinear function is a function for which the graph is not a straight line. There are a number of examples of that, and we'll just be looking at a few in this section. So the vertical line test. In this green curve, we'll see that the blue dashed line that's dropped is a vertical line, vertical meaning up and down, and it actually intersects that graph at 2 points. That means for the input of 1, there's 2 different places where it crosses the graph. So that graph is not the graph of a function. Here on this next one, the vertical line is only intersecting once, and there is no place along that green curve where you can get it to intersect twice. Let me just mention that this section in here is all asymptotic, and so while it may look like you're touching the y-axis for a significant period of time, the only place that it does touch the y-axis is the origin, and it's coming asymptotically close to the y-axis at all those other points. So that is the graph of a function. And then the last thing we'll look at is a basic line. It's a line with a negative slope. A vertical line, anywhere you dropped it down along that line, would only intersect once, so it is the graph of a function. Whoa. It is the graph of a function. So let's talk about linear functions for just a minute, okay? Linear functions are not exactly the same as linear equations because there are a handful of linear equations that are not functions, and we will talk about what those are. The first thing I want to do is just review the graphing of linear equations as we get into talking about which ones are functions. And I'm going to graph 2 ways here. The first way I'm going to graph is right here in this example. I'm going to graph using intercepts. So I'm going to find the x-intercept by setting y equal to 0, and I'll get 2x equals 6, or x equals 3. So I'll put that here. 3, 0 is this point. That's the x-intercept. And we always want to label both of our axes too anytime we're drawing a graph. Next, I'm going to find the y-intercept by setting x equal to 0. So I'll get 3y equals 6 and y equals 2. So that's the point 2, 0. And then what I want to do is I want to take my handy-dandy straight edge. All straight lines should be drawn with a straight edge. Always, always, always. Okay, so all straight lines need to be drawn with a straight edge. So what we want to do here is draw this line with the straight edge, which means I've got to grab my pen and draw it with a straight edge. Arrows on the end. And then what we want to do is we want to label that line with its original equation. Now the second way I want to graph this, 2x, is I want to graph it from slope-intercept form. I'm going to mark my x and y axes first again. This time I'm going to solve for y. So I will subtract 2x from both sides, and I'll have 3y equals negative 2x plus 6. Divide all terms by 3, and I'll get y equals negative 2/3 x plus 2. And then I'll put on that 0, 2, that y-intercept, and then I go down 2 and over 3, and I just happen to end up at the x-intercept. That doesn't always happen. And then I go down 2 and over 3, and I end up at negative 2, comma, whoops, that is not right. I end up at 6, comma, negative 2. And that is 3, 0. I don't know what's getting into me. Okay, 3, 0. I hope all of you were internally screaming when you saw what I've written and ready to tell me how wrong I was. Okay, now I'm going to take my straight edge, connect the dots, arrows on the end, and again I'm going to label it with the original equation. Now this particular line is a function. It passes the vertical line test. So every input of x, there is one and only one output of y. So I want to look at a couple properties here. Since we can write it in this form, this slope-intercept form, that means we can also write it using function notation. So that's the first thing I want to point out, that any linear equation that you can write in slope-intercept form, y equals mx plus b, you can also write using function notation. So it is a function. Keep in the back of your mind, maybe be thinking about what might not be a function that could be a line. The other thing I want to say is what the domain and range of a line are. If a line is a function, except for two very special cases that we will look at in a minute, the domain is all real numbers, and the range is all real numbers. Now what are these two special cases? They're horizontal and vertical lines. So let's first look at this horizontal line, y equals 4. Well, this one you can write as f of x equals 4. We call that the constant function. It is a function. It passes the vertical line test. It's written in function notation. Its domain is the real numbers, but its range is 4. That should be fancy schmancy brackets. I'll rewrite that so it looks better. Okay, so a horizontal line is a function. It's a constant function. The range is limited to just that constant. Let's look over at this line right here, this x equals 4. There is no way to write that in function notation. There's no way to write f of x equals something. And this so does not pass the vertical line test, because look at this. I'll take a different color for it. But if we drew a vertical line down here at x equals 4, we will get an infinite number of places where it intersects. It will be a collinear situation. So a vertical line is not a function. It is the only linear equation that is not also a linear function. Nonlinear functions, I want to talk about these for a while and just identify whether something is a linear or nonlinear function and what names we give to some of these nonlinear functions. You'll probably remember this from a couple quarters ago in math, a quarter or two ago. This is called a quadratic. Anytime you have a squared term here, this is a quadratic function. We will be doing a lot of work with quadratic functions in this course. This next one down here is actually a linear function. I hope you recognized that when you saw it. It's in the form y equals mx plus b. This is not what I meant to write here. Scratch this out for a minute. I meant to write 5 over x. Okay. Sorry about that. X over 5 would be a line. 5 over x is called a rational function. When you have rational functions, that means you end up with x's in the denominators. So remember those restrictions. In this case, the domain is all real numbers except 0, because you cannot divide by 0. This last one I'm just going to call a polynomial function. That covers anything with any exponents. This is a special type of polynomial function, and it's a cubic. We name quadratics and cubics, but we don't name beyond that. We just call them polynomial functions. The last type of function that I want to look at, which is called an absolute value function. So this is your absolute value function. Okay? So you're saying that the function of x, f of x, equals the absolute value of x. And remember, absolute value takes away the positive and negative and just gives you distance from the origin. So I'm going to do this, I'm going to mark x and y to be good, okay? And then I'm going to do this by doing a table of values just to show you kind of how it's going to work. So I'll do x, I'll do 2, 1, 0, negative 1, negative 2. And what do I get for y? Well, what's the absolute value of 2? It's 2. The absolute value of 1 is 1. The absolute value of 0 is 0. The absolute value of negative 1 is 1. And the absolute value of negative 2 is 2. So let me go ahead and put these on here. 2, 1, 0, negative 1, 1, negative 2, 2. And what's going to happen with